Well, hi there, boys and girls. I put this PowerPoint up on Edline, and I want you to go grab this PowerPoint called Inverse Trig Functions. It's also on our calendar. And I'm going to do something a little different with this video. I want to talk you through some of the key points of this PowerPoint, and I don't want you to write hardly anything down. I'm going to circle things I want you to write down, but it won't be much. So you won't really take a bunch of notes here, but I do want you to watch the PowerPoint. But don't watch the PowerPoint until after I talk you through a few things. So you're going to only have, you'll have very minimal things written down for your notes. Tomorrow we're going to go over how to graph these things. So I want you to grab this PowerPoint off of Edline, but I don't want you to write anything down unless I tell you to write it down. After that, I want you to just watch the PowerPoint by clicking through it. So here we go. We're going to talk about inverse trig functions. And before we do that, we're going to talk about what an inverse function is. So again, I don't want you writing this down. I'm just talking to you right now. An inverse function is something that's supposed to undo another function. For example, if I told you I squared another, squared a number, you're supposed to be able to get back to what number I squared. However, if I said I squared a number and I got 9, you don't know what I squared. I could have squared -3. I could have also squared 3. And that is because x squared is not what's called a one-to-one function. It does not pass the horizontal line test. Do not write this stuff down, folks. Please don't be writing this down. Just listen to me. I'm talking you through this, and then go watch the PowerPoint. Okay, so you can tell from this graph of x squared that there are actually two places where x squared is 4, 2 and -2. And so there's no way for me to undo. If I said I squared a number and I got 4, you wouldn't know which one I picked, whether it was -2 or 2. So this graph right now does not have an inverse function yet. There's no way to undo it. So what we do is we restrict the domain. We say, okay, I'll talk about x squared, but only for x is greater than or equal to 0. That way you can use the square root graph to get back to my original answer. And notice again, inverse functions are symmetric across the line y equals x. And you are not writing this down, right? Don't do it. Don't write all this down. Okay, so that's just the motivation. So that's what we have to do. Now you'll notice here that the sine graph fails the horizontal line test miserably. Any horizontal line between -1 and 1 will intersect sine, well, an infinite number of times. So what we have to do is we have to restrict the domain and only look at all of the values from -1 to 1, but we are going to restrict our domain. So we're going to take a piece of this graph. And so here's what we're going to do. We're going to zoom in from -π/2 to +π/2. Now the reason we choose this window, we could have chose other windows, but the general convention, sorry, I bit my tongue, convention is that we choose from -π/2 to π/2. That's because that hits every single y value from -1 to 1. Alright, and so this is what the sine graph looks like from -π/2 to +π/2, and you can see we hit all of these y values between -1 and 1. Now an inverse graph will switch the domain and range. And we're going to graph these actually tomorrow, and we'll see what they look like. But right now I'm just talking you through this. We switch the domain and the range, and then we'll get a graph of what's called the arc sine graph. And that arc sine is right here in blue. We're going to do this tomorrow. I'm just talking to you through this. And you're not writing this down, right? Okay, good. Also, arc sine is the same thing as sine to the -1. Don't write anything down yet. Alright, so unless you're told to do so, we're going to do our inverse sine and inverse cosine and inverse tangent using radians. But something that's very important here is whenever you do inverse sine, your answer is an angle. And so the input is the fraction and the output is the angle. So that's very important. When you answer arc sine, you're giving an angle. Okay, so now on cosine, we can't do -π/2 to +π/2, because if we do that, we are missing all of the negative y values. So we have a different restriction on our domain for cosine. Our restriction is going to be from 0 to pi, because that's where we get all of the values from -1 to 1. And in class tomorrow, we're going to actually graph the arc cosine. If you switch your domain and range, this is what the picture you get. We are doing this tomorrow in class. Okay, now for tangent, if you go from negative pi over 2 to pi over 2, you get the full picture of tangents. So that's easier to do. So we just look from negative pi over 2 to positive pi over 2, and we flip the domain in the range. All right, so tomorrow in class, now this is something that you are going to write down. So write this table down. Just the table, because from this information we are going to try and graph these tomorrow. Okay, so after you write this down, I want you to go watch the PowerPoint. That's it. Don't write anything else down, and then we're going to graph these thingies tomorrow, and I will see you then.